Today we're going to continue our work on the ellipse, and we're going to look at question 6, higher level from 2006. Topics that will be covered in this are the parabola, as you can see, AB, vertex being at A, and it needs to be repeated underneath going BC. Then we have an ellipse where we're given the major axis and a point in the curve, and we're going to use a little bit of axial symmetry to speed the whole process up. Okay. So I'm going to start off today drawing my horizontal center line, and I'm going to throw down onto this horizontal line as many widths as I can to get the ball rolling. As I said in previous questions, I prefer to answer the question as it's asked. Now, some teachers might recommend to do it differently, but seeing as the parabola is the first thing mentioned in the question, the parabola is the first thing that I'm going to do. If you prefer to start at the ellipse and get that bit done first, that's absolutely fine by me as well. It's just something that I've got into the habit of, and I find it helpful in that it prevents me from missing out on anything that's asked in the question that I don't pick up on, answering it piece by piece. You'll see from the video here, I'm using my compass to mark off my heights. So I use my compass as often as possible, in particular when I'm marking the same height more than once, as you can see me doing. In terms of accuracy, I think you're not going to get a better way of transferring heights. There's always margin for little error if you're using your set square to measure the distance. So where possible, use your compass, set the height, and mark it off accordingly as such. Labeling is key, guys. Okay, so always label as soon as you can, and try and use the same labels that are on the actual question booklet. It makes it very helpful as the process goes. As I said, we're going to start with the parabola, and you can see now it's easy to get confused by thinking that the vertex is actually at point B on the left hand side where my set square is now. Don't be fooled by this, okay? The information is in the question, okay, and we're told that the vertex is at A, and I'll be drawing my horizontal line beginning from A right there right now, okay? So what we need to do is we need to divide the vertical line on the left into an equal number of parts, okay? And I'm showing you the construction to do this now. So from one of the ends, set off a random angle with your set square and set your compass to a random distance and swing it off however many times you want to divide it up. In this case, I've picked 5. Okay, on the final division point, using your set square and your pencil, join it back to the end of the line that you're looking to divide. And you'll see me doing that now. Okay, so the final division point there, put my pencil on it, angle it back until the end of the line I'm looking to divide, draw my line, and we're going to draw parallel lines back going through each compass point that we scribed off on that line. That divides our vertical line perfectly into 5 equal parts. In this case, if you wanted to divide it into 3, you would have stepped off 3 times with your compass, etc. So when we've that done, we now need to divide up the horizontal distance into the same equal number of parts. And we know that it's 150 millimeters complete fully, so we're going to divide that by 5, and that gives us 30, 30, 30. So I've made a little bit of a mistake there, so you can see me moving it out. I was using the wrong measurement. So Just take your time. Now you could use the same construction that I used on the left hand side, drawing a random line off at an angle, stepping out an equal distance 5 times, but I've chosen not to do that because we've got a distance 150 millimeters divided by 5. It gives us 30 perfectly. So I'm just going to do that with my set square. We're on to the parabola now, and the drawing of the parabola, the construction of it. So you can see I'm drawing my 5 lines that I divided up vertically, and I'm going to label starting at 0 down there, 1, 2, 3 and 4 going up my vertical line, and I'm going to go 1, 2, 3 and 4 on my horizontal line, and lines 1 will correspond with one another. So I join line 1 on the vertical line back to the vertex, and where this cuts my vertical line number 1 here, that gives me a point in my parabola. I carry out the same process for point 2 back to the vertex, where the diagonal line 2 just drawn cuts the vertical line 2, I get another point. The same for 3 and for 4. Now this is a step that a lot of students forget. An awful lot of times students forget that they have to join the lines at an incline back to the vertex. Often you'll see students draw horizontal lines there, and your parabolic curve, when you do it like that, ends up being a straight line. Okay. When you're happy with the points, I always do a sort of a visual sort of dry run over the points before I actually start to heavy them in. I then heavy them in lightly, and when I'm happy with my curve, I'll heavy them in fully. For the corresponding parabola underneath it, we could use the same construction that we used to complete the first piece. However, we've already shown the examiner that we know the construction for a parabola. So you can see by my hand movement there, we're just going to fold this shape down over as if that horizontal line is the spine of a book. And this process, as you may or may not know, is known as axial symmetry. So we're going to use axial symmetry to transfer these distances down, as you can see I'm doing. And again, when we're happy with the points, we'll do our dry run over the curve. We'll heavy it, or we'll draw it lightly, and then we'll heavy it in finally when we're happy with it. Now it's time to draw our ellipse, and you can see I've identified the center point 0. Now take your time finding this, because if you start off in the wrong place, you're going to struggle to get it back. There's so much construction associated with this. So in this question, we're given our major axis, and I've just drawn it there, and we're given 2 points on the curve E and D. Okay, so we're going to work with 1 point. And as usual, I recommend drawing a quick sketch as to how you draw an ellipse. I remember when I was in school being asked to learn these different constructions of how to draw an ellipse, you're given a major axis and point in the curve, etc. And I could never remember it. So for me, the easiest way is to draw a little sketch as if you were drawing it, and that's point that I've just drawn in the sketch corresponds to point F in our drawing. Now look at the vertical line from point F. We draw a vertical line until it hits the major circle, as we did in the sketch. And then from that point, we draw back to the center point. As you can see me highlighting it in the sketch, I'm going to do the exact same thing here now. So from that point back to my center point, and we'll return back to our sketch. And we can see that there's a horizontal line that cuts across from point F until it cuts that line that I've just drawn. So from F, we cut across, okay, until we cut that line going back to the center point. And using our compass now, we can now draw our minor axis, okay? That distance, as you'll see in a second when I remove my hand, that distance there is our minor axis, our minor radius, apologies. So when we draw our minor circle, we can draw our ellipse. Again, you can draw the ellipse whatever way you see fit. There are a number of different methods. I'm using the concentric circles method here. I find it the quickest, most accurate way of doing it. When you've found all your points, as I'm doing right now, be sure to take another sort of a trial run of your sketch. Then start going over it lightly. Make sure you're happy with your sketch before heaving it in. Remember, there's about 12% of the marks go for neatness and accuracy in how you present the question. So it's well worth taking your time and making sure you're dead happy with this, with the quality of your freehand sketching here. Again, we're going to use a little bit of axial symmetry here to finish off your question. And you can see actually the little piece of work to the right hand side of the vertical line that I'm just hovering down over shouldn't have been heavied in, and I'll address that afterwards. But as you can see, I'm taking random points from the ellipse on the right hand side, and I'm going to use that vertical line again as an axis. Using my compass, I'm going to transfer my distances over to get an exact replica of the curve that I've just drawn. This will help me finish it, so you can see this process going on.